Hey, what's up? Welcome back to Morgan's Quick Snips. Right now I'm going to show you how to use a compass to construct Snowman City Hall, which all of you have seen and it was asked. So if you recognize, that's the hexagon that you had to make. You also are required to have a triangle inside of a circle on both sides. So this video that you are about to watch will demonstrate just that. So here we go. I'm going to turn to a new page. We know that the needle stands for the center of the circle and the pencil will make the circle. So this, from the needle to the tip of the pencil, is the radius that we'll use to construct our hexagon. That's about 1 inch. So I have a radius of 1 inch, and I'm going to go ahead and I'm going to place it on my paper, and notice that I'm just going to twist until I make a complete circle. Awesome. Then I'm going to take the radius, the center of the circle, and place it anywhere on the circle, and I'm going to complete this process again. Make another circle. Awesome, we're doing great. So I noticed that the circle intersects at 2 points. And since the circle intersects at 2 points, what I'm going to do is I'm going to place the center at one of the intersecting points of the original circle. 2 circles. And there we go. Now, go up, and I'm going to put a point at each intersection. Yeah, there we go. So I'm going to go ahead and I'm going to construct my first triangle, my initial triangle. My initial triangle is when I connect the radii of the 3 circles. How many? Each radii. Each center of the circle has how many radii coming from it? Your answer should be 2. Great. Now, but before I pick up my compass again, I also noticed that I could do some other stuff. I have 3 other intersecting points. So I'm going to go ahead and I'm going to mark this point here for this intersection, mark this point here for this intersection. And what do I notice about these 3 points? They're all what? Collinear. Great. You guys have excellent vocabulary. Now when I connect this point to this point, this chord of this circle completes my second triangle. This chord makes my 3rd triangle. And what shape do I have? The composite shape of 3 triangles, 3 equilateral triangles, will make a trapezoid. Great job. Now, what I also know I need to do is I'm going to need to extend a triangle to the left and to the right, and I also need to figure out how I'm going to get this trapezoid here. So, what I've noticed is if I put the center of my next circle at the vertex of this trapezoid, without changing the distance between the pencil and the radius, the pencil and the center of the circle, then I'm making sure that my radii are exactly congruent. And while I'm using this tool, I want to go ahead and do the same thing at the left vertex. Make sure that I have it on that point. Again, without changing the distance from the center of the circle to the pencil, without changing the radius. Look at what I have. Awesome. So now, again, I have some new intersecting points. I have this intersecting point and this intersecting point. You see any other intersecting points? You're right, I have an intersecting point here, an intersecting point here. Let's complete our hexagon. How are we going to complete our hexagon? You're correct. We are going to connect the center of this circle to this side of this chord of the initial circle. So there's 1 chord. And I'm going to go ahead and notice what I notice about all 3 points. They are what? All 3 points. Let me see it, show you so you can see. All 3 points are collinear. Exactly. I'm going to do the exact same thing on this side. Make sure that I have this at the intersecting point. And there we go. And what do I notice about these 3 points again? They are collinear. You're learning some strong vocabulary. Collinear means all 3 three vertices lie on the same line. I'm going to go ahead and connect this cord here, and I now have my hexagon. Yay! I made a hexagon! I made a hexagon! I'm going to go ahead and trace this hexagon so you can see it. There's a hexagon. But we remembered that Snowman City has what? It has a hexagon, and then it has two inscribed triangles. Now, what do you think these points, intersecting points, have to do with the inscribed triangles inside of a circle? Correct. We're going to go ahead and connect this point. Look at what we notice about all 4 points. About this point, this point, this point. What's that magic word we've been talking about? Collinear! Great job. I take my collinear points. Yay! I'm going to go ahead. I'm going to close this off. Yay! And it's what to these? It's collinear! Yay! What I notice over here? The points are what? Collinear! Yay! I'm going to see them clearly. Now, there's something I have to do with these in order to make sure that they are inscribed in the circle. If something touches the circle only at one point, it's considered what? That was that magic word that started with a T. I know people in Ms. Lionel's class knows this answer. That's right, in their tangent, but since they're going to touch at 3 specific points where the vertices lie on the circle, that will be the definition of inscribed. So in order to find the center of the vertices that is perpendicular through each side, so I'm going to take my radius and I'm going to adjust it to where it's slightly larger than half the distance, right? Because I really don't want to measure it. And boom. I'm going to make it an arc to go through both sides because I'm going to need it that way anyway. I'm going to pick it up, put it at the next vertex of this triangle. Yay! And as I twist, what do I notice about this point, and this point? That is correct. This line is perpendicular. This will bisect at a 90-degree angle, but it also has perpendicular bisector. We're going to repeat that process on the other vertices as well, okay? So I'm going to come here, the third vertices, make my arc. Yay! And what am I bisecting? That's bisected. Well, I should have kept it going, so I can make sure. Then this one, I should have kept it going. You'll see it. And notice each side that's bisected is perpendicular. Notice the bisecting points. They are perpendicular. Now that's a very special geometry word you're going to learn in high school. But no, this is. Now, notice the relationship between the center of that triangle and the distance from the vertex. Hey, it's congruent. I'm going to adjust. Look at what I have. Yay! I now know. I've now inscribed a triangle because the triangle and the circle share the same center. Now, I'm going to do the same thing on this side without changing the measures. I want you to tell me what you notice. Here's my center of my circle movement. Let's do that a little better. Make sure that it passes through both sides. Let's make sure that on this vertex, that the arc passes through both sides. Notice what happened this time since these two triangles are congruent, and I did not change the distance of the original, change the distance of the circle that I used to inscribe this triangle. When they intersected where? At the center of the circle. And because I have not changed the distance from the needle to the pencil, change the distance of the radius, notice that I have my second inscribed triangle. Beautiful. Circle in blue so you can see it. And that is how you use your compass to construct Snowman City Hall. Now, some of you may want to go back and